Hello everyone, welcome to the Data Center Academy. On this platform, you will find in depth knowledge based data center videos which will definitely enhance your understanding and expertise. Let's start with the first basic lecture, which is a data center introduction and overview. Before that, I would like to introduce myself. My name is Basit Amin and I am a data center engineer. Apart from engineering qualifications, I have few data center certifications and many other relevant certificates as well. These data center certifications include CDFOM, CDFOS, CDCP, CDCTP, FM, FC, etc. Okay, let's start the lecture. First section is introduction to data centers, and the very first basic question is what is a data center? As the name suggests, data center. So a center can be a building, a place. So a center which manages or deals the data. A data can be a storage or any electronic data. So basically, a data center is a building, is a place, a dedicated space within a building, or a group of buildings used to house computer systems and associated components such as telecommunications and storage systems. They are designed to manage security, redundancy, and efficient processing of data in a centralized location. The second question is, why are data centers important? Obviously, it is a digital world. So, data centers are essential for storing and managing vast amount of data securely. They support the functionalities of numerous applications, websites, and online services, integral to daily operation for business and organizations. So, the brief history of data centers, the concept of data centers began in the 1950s with the advent of mainframe computers evolving rapidly alongside technology advancements. The 1980s and 1990s saw a shift towards dedicated facilities influenced by the increasing demand for data processing and storage. Well, this was the basic first section, just two questions and the history. So, the second section is types of data centers. Roughly and commonly, there are five types of data centers. First type is enterprise data centers. Enterprise data centers are built and operated by a company for its own exclusive use. So these facilities are tailored to the organization's specific requirements. So these data centers are relatively small data centers. Second type is co-location data centers. Co-location data center is a rent a business where the owner rents its space, means building, cooling, power, connectivity, physical security, fire safety, and others as well, etc. And the customer who rents those space, though they provide servers and storage. So, in a co-location data center, there might be one business or there might be multiple businesses or clients or customers, or you can say companies as well. Third type is hyperscale data centers. Hyperscale data centers basically they are operated by large cloud service providers such as AWS, Microsoft, Google, etc. Next one is edge data centers. Edge data centers are located close to the edge of a network. They provide a similar facility infrastructure found in traditional data centers but are contained in a smaller footprint and closer to end user and devices. The objective is to provide the quickest content delivery to the end device that may need it with as little latency as possible. The last one is cloud data centers. In a cloud data center, you can rent both space and infrastructure. cloud providers maintain large data centers with full security and compliance. A major difference between a cloud data center and an enterprise data center is scale. Enterprise data center is solely operated for that particular organization, whereas a cloud service provider operates a data center for many customers, and therefore these data centers may be much time larger than the enterprise data centers. So the next section is data center tier classifications. First tier is tier 1, a data center with a single path for power and cooling and no backup components. This tier has an expected uptime of 99.67% per year or less than that, since its component redundancy level is zero. So, in case of fault, the client would have to suffer discontinuity starting from few minutes to several minutes or couple of hours. Tier 2, a data center with a single path for power and cooling and some redundant and backup components. This tier offers an expected uptime of 99.741% per year. Component redundancy is partial and plus 1. Technically, the smaller organizations or the new organizations, they prefer tier 1, which is the cheapest one. So the organizations which are on the growing stage, they prefer tier 2 because they have partial and plus 1. Obviously, they have a single path like tier 1, but they have some redundant components as well. It means in case of fault, they will come back quicker than tier 1. Tier 3, a data center with multiple paths for power and cooling and redundant systems that allow the staff to work on the setup without taking it offline. So it means in Tier 3 system or the data center, it will never ever go down. Expected is it will never be down. So this tire has an expected uptime of 99.982% per year, and its redundancy is full n plus 1. So its downtime per year is considered to be less than 1.6 hours. So basically, the successful organizations, they prefer tier 3, and obviously it's expensive option as well. Last is Tier 4. It's a completely fault tolerant data center with redundancy for every component. This tier comes with an expected uptime of 99.995% per year. Its component redundancy is 2n or 2n plus 1. 2n means we have two lines for both for power and cooling as well, and 2n plus 1 means we have two lines for both power and cooling, and plus 1 means we have redundant components as well. It means 100% for nearly 100% fault tolerance. A fault tolerance facility ideal for consistently high levels of traffic or processing demands. Basically, government entities and large enterprises, they prefer tier 1, tier 4, because tier 4 is the most expensive one. Next section is infrastructure components. The first is servers. Obviously, servers as the backbone of a data center, handling data processing, storage, and application management. Modern data centers utilize high density server configuration to maximize computational power while minimizing space requirements. In servers, you put storage devices, so where data is being stored over there. So these servers, they send or receive data, and they communicate with other servers and with other data centers or with the customers, clients. So the other thing is storage system. Systems are critical for data retrieval and management, employing various technologies including SSDs and HDDs. Nowadays, everyone uses SSDs, obviously, but they are the expensive ones. They ensure high availability and redundancy to prevent data loss and maintain business continuity. So we store the data in these storage devices. We put those storage devices in the servers, and we put those servers in the server racks, and we keep those server racks in a hall or in a place which we call it data hall. And I explain this in my next lecture. So next is networking. Robust networking infrastructure connects servers and storage systems, facilitating data transfer and communication. This includes routers, switches, and firewalls, which ensure secure and efficient data flow within the data centers. So, through this networking, we connect one server with the other one, and we connect these servers with the client, with the customer, and obviously they are, so we use fibers networking to send or receive the data. The last one is power and cooling system. Obviously everyone knows that to run those devices, to store the data, to run the servers, we need power. And obviously servers, they emit heat, and to control the heat we have to use cooling systems. There are a lot of options like crack units, and so I will explain them later. And so data center requires sophisticated power and cooling systems to support operations and prevent overheating. That's what I already mentioned. So the last section is operation and management. The first is monitoring and maintenance. Monitoring is very, very important in a data center because servers, they emit heat. So if the servers, they overheat, if data all overheats, so obviously we would be in trouble. So there can be a chance of fire and other issues as well. So to control the temperature and to control the humidity, we have to monitor the temperature and humidity of the data hall all the time, 24 by 7, 365 days in a year. And maintenance, second thing is maintenance. So because data center is operational 365 days in a year, so it needs maintenance as well. So continuous monitoring and maintenance ensures optimal performance and early detection of issues. I will explain this later as well. Security measures. Data centers are the critical environments, and they are the most secure buildings. So because they have the customer data, so they should be secured at any cost. So next is disaster recovery. Let's say in case of any disaster and you lost your data. Let's say there is a fire in a data hall and you lost everything. So there should be a backup plan for the data. Let's say if data A is deleted, then you would have a backup option and you would have a backup. So the same copy would be stored in another data center as well. So there should be a disaster recovery option as well, sorry, data and disaster recovery plan as well. So the next is risk factors. Because data centers are the critical environment, so there are a lot of risk factors as well. The most risk factor is human errors, the biggest risk factors. The other one is equipment failure, heat, cold, humidity, lighting, air pollution, sabotage, earthquakes, so virus, etc, etc. Human error is in case of, let's say, human error refers to a mistake or failure made by a person resulting in an unintended outcome or a failure to achieve a desired goal, often due to slips, lapses, or mistakes, and like that. So the other is future trends. These are the future trends. So, well, I hope you liked my video. I will share the other lectures in my next videos.